So let us start part 3 of our mathematics chapter sets. So today we are going to learn about Venn diagram. These Venn diagrams, basically they are named after John Venn. He was the English logician, and based on that, basically this Venn diagram concept was developed. Correct? Now let us see, suppose you have a universal set, that is 1, 2, 3, that is up to 10. This is the universal set. And A is the subset of this. Correct? So pictorially, we can show like this. We have to make a Venn diagram. Here, what is this? This rectangular shows your universal set, universal set, correct? Then another, we can make a circle. What is this? This is your A. This is your set A. As all the components, all the elements, they belong to you. Here, basically A is subset of U. So we can write it here. Here 2 is there, 4 is there, then 6 is there, 8 is there, 10 is there. These are the elements which belong to set A, and universal set, what is left basically 1, 5, 9, 7 and 3. So in the universal set, basically if you see from 1 to 10, all the figures are there, but the figures which do not contained in set A, they have been written outside, but that is the part of the universal set. So this is called pictorial representation of sets, right? Basically it is called Venn diagram. Now let us see what is operation of sets. Operation of sets, basically let us define A, that is union of sets. Union of set means if A and B, there are two sets, like A is 2, 4, 6, 8, and your B is suppose 6, 8, 10, 12. So union is basically denoted by this symbol. So A union B will be what? Now, whatever elements are there, A and B, we have to write all those elements. That is the union. 2, 4, 6, 8, 10, 12. Correct. So this is the union. Then if you want to show this thing as a Venn diagram, then we can show like this. This is your universal set, and here this is your set A, and this is your set B. This is your set A, and this is your set B. If you see A and B, these here basically 2 and 4, 6 and 8 are common. So here we can write 6 and 8 and 10 and 12. Correct? So here, what is the A union B? It is nothing but the complete this is the A union B, you can say. Correct. Now we have some properties of A union B. A union B is equal to B union A. There is no problem. It is called commutative. Commutative law. Correct. Then let us see another property, that is A union B subgroup, and union C means A union B union C. This will also be always equal, and this is called associative law. Now, third one, A union phi. Phi has got no element, but A has got elements. Correct. So this is nothing but A will be A only. Correct. Then what about this? This will be basically A only, because all the elements of A will be A union A also. There is no problem. This is called idempotent law. And if you see union of universal set union A will nothing but, of course, universal set, it is called law universal set. So this is about A union B, union of sets. This is how. Then let us go to the another B, intersection of sets. Intersection of sets means what is common in them. It is denoted by inverted U. Correct. Suppose in the above example, as we have seen, in this example, A is this and B is this. We have found out A union B. But if we find A intersection B, then it will be nothing but 6 and 8, because only 6 and 8 elements are common to them. Here we can see through Venn diagram also. Suppose you have a set A, you have a set B, then A intersection B means the common portion of this. So what is the common portion? This is the common portion. This is basically A intersection. Here it was A union B. Correct? Now, suppose what is a disjoint set? If A intersection B is 5, means there are no elements which are common, then they are called disjoint sets. Pictorially we can see, we have through Venn diagram, you can show them like this. This is your rectangle universal set. And one set A is there and another set B is there. Set A is there, set B is there. But there are no common sets. Correct? So this is basically a disjoint set. Now let us see some operations of this intersection also. One, commutative, that is A intersection B is B intersection A. There is no problem. Commutative law holds good in this also. Then A intersection B intersection C is nothing but A intersection B intersection C. Associative law also holds good. Then phi is phi intersection of A will be what? Phi only, because phi has got no element. That means phi intersection of A has got no element. And if universal section intersection of A will be A, correct? Then A intersection of A will be A only, because all the elements they are existing in A. Correct? This is called idempotent law. Correct? Then there is a distributive law also. A intersection B union C. A intersection of B, this A intersection of C. This is basically called distributive law. Correct. Let us see this thing as a Venn diagram. Suppose you have you have this is A, then this is B, and another one is also because C is also there. So you can have like this C. Let us copy this because this will be used a number of times. Now let us see B B union C. B union C. What is this? B union C is nothing but this is correct. Now this is your B union C and then A intersection of B union C. So we have to see what is common between them. B union C and A. What is common? Common is nothing but only this much. So portion of the B union C, it is common to A only this much. So what is this? This is intersection of B union C. Correct. Now here let us see A union B. A union B, you can see this is like this. Correct. And A union C. A union C is nothing but this is like this. Now A union B and A union C. Just see these two figures. What now we have to find out intersection of these two figures. So if you see intersection of these two figures, then what is the intersection of these two figures? you will find this only. This is what? This is your A union B, intersection of B union C. So through Venn diagram, you can prove it. Right? Now, further, we let us go to the another topic, that is difference of sets means A minus B or A minus, like that. Suppose you have A 1, 2, 3, 4, 5, 6, and you have B 2, 4, 6, 8. Then what is A minus B? A minus B is nothing but they are the elements which belong to A but do not belong to B. So here A minus B will be nothing but 1, 3, 5. Because 1, 3, 5 do not belong to B. Likewise, if we, so B, the element of B which do not belong to A, and if we see only element, that is 8, is the element of B which do not belong to A. Correct? Here you can see A minus B is not equal to, correct? Now, Venn diagram, if you see, so suppose you have A and another one is you have B. So this is your A, this is your B. Some elements are common to them. Then, if you shade this portion, what is this? This is your A minus B. Okay? And if you shade this, then what is this portion? This portion is B minus A. Correct? Now, let us see further what is remaining in the chapter. That is complement of a set. Complement of what is complement of a set? Complement of a set is basically, suppose you have a universal set and you have a set A contained in universal set, or you can say A is a subset of. Then what is complement? Complement is basically is denoted by A dash. Complement of A is nothing but U minus A. Correct? Here we can see in the Venn diagram, if you want to see, suppose you have a set A and this is your U. Then what is this portion? Suppose if I shade this portion, this portion is basically A dash, and A dash is nothing but U minus. So this is the complement of A. Correct? We can take a example here. Suppose U is your natural numbers up to 1 to 10, and A is your, it comprises 1, 3, 5, 7, 9. Only 5 elements. Then what is A dash? A dash is nothing but U minus A, and just see what are the elements of U which do not belong to A, and those will be 2, 4, 6, 8, 10. Correct? So this is how you can define the complement of a set. Naturally, if there is some complement, if you take the complement of this set is nothing but the set itself. Correct? Let us take an example. Suppose U is your 1, 2, 3, 4, 5, 6, and A is 2, 3, and B is 3, 4, 5. That means, let us find out what is A. A dash means complement of A. Complement of A, you can see it will be nothing but 1, 4, 5, 6. What about B dash? B dash is nothing but 1, 2, 6. Now, what about union, intersection of this? That is nothing but 1 and 6. Correct? Let us find out what is A union B. A union B is nothing but 2, 3, 4, 5. Up, suppose you have this set, complement of this, let us see. That will be 1 and 6. Just see this and this. That means A union B complement of this will be equal to A complement intersection of. So remember this result. A union B complement of this is nothing but A complement intersection of. Correct. Now there are some properties of complement set. It's very important. One is complement laws. Like A intersection of A dash would be U only. It is quite natural. Then another thing is A intersection of A dash is nothing but because they are disjoint sets. It will be 5 only. Then there is a De Morgan's law. De Morgan's law, which it states that A union B intersection of this A union, sorry, yes, A intersection of this. This we have seen earlier. And A intersection B will be nothing but A correct. We can find out here what is A intersection B. In this A intersection B, there is only one element common, correct? Then complement of this, what will be the complement of A? That we have already, sorry. Here basically we are finding out intersection. What is the complement of this? Complement will be nothing but your one, two, four, 5, 6. I think that is correct. It will be the complement of this, and then we have union of this, A dash union of B. If you see, we have A dash and B dash. Both are given. We can write it as 2, 4, 5, 6. Correct. So that way, this is also proved. Then we have 3, law of double complement. That is A dash. It is quite natural. Then law of empty sets and universal set, that is phi dash is nothing but universal set, and universe complement of universal set is nothing but phi. These are quite natural. Correct. So this is the complete chapter of your sets. Correct. So just go through it. Everything I have contained or covered in this chapter, and time to time we will bring another chapter of mathematics at this platform. Our idea is to cover all the chapters of NCERT class 11th and 12th on this platform. So keep visiting this channel and keep subscribe this channel so that whenever I publish any video or whenever I am live, the notifications you should get and you can have the advantage of that. So please share in the comment box how did you like this video. Correct. And you subscribe my channel also, because a lot many more things are going to come on this channel. Thank you very much.